Hello, college algebra student. This video is for chapter 6.5, Properties of Log Function, part 2. We learned the three properties of log, which is the product, quotient, and power. So if they multiply, they add. If they are dividing, then you can split it as the subtraction. And then if there's a power inside a log, you can move the power as a coefficient, which is very useful when you solve equation. And also when you simplify a log. So we did some basic, setup of using those log properties. Now we're going to use them all together. So now the criteria of using them is, which one should we use first? Is when we expand add and we expand into add and subtract first. So we keep each individual factor with the exponent and expand it first. And then we expand the power. Okay, so this is first use the product or quotient. You can use it together first. And lastly, then use the power rule for expansion. Okay. So you'll see that this things is multiplied with this is divided with z to the 4. So don't move this out because they will be competing. So which one should move? Because these are all exponent, right? So what you do is you expand them as log base 10, of course, is x squared. Because these are multiplying, so you expand as log, add cube root of y, and then minus z to the 4 power. Right, so that's the first expansion. And then you say, oh, this is now an individual log with 1 power now. So I can move this out. 2 log x plus y, cube root of y is y to the 1/3, right? It's the same as y to the 1/3. Cube root of y is actually y to the 1/3. If you want to, you can do one more step to write them as exponent. But you can just move it outside as 1/3 log y. You don't do root outside. You move it as 1/3 outside of it. Minus, so this z is in the log, so you can move it as 4 log z. And there you have expand them, all of them into individual. So these are individual with just log of something, log of something, and log of something. So that's what they want. So the second one, so now if I have one big exponent like this, so earlier I say you expand the individual one first. So but I don't have individual one because they're all inside a big log, big square root. So what you do is you would get rid of this first because it's just one thing. So you would treat this as one thing and move this out first. So you would write it as log base 10, I guess, a cubed b negative 5. And the whole thing is to the power 1/2. So you treat this as log something to the power 1/2. Now you can move it outside. So 1/2 of, so keep this, okay, log a cubed b negative 5. Now you can look at inside. This is a multiplication. So you don't take care of the 3 and negative 5 exponent first. So don't move them out, but take care of the multiplying first. This is very confusing. So be log a cubed. This is multiplying, so you can do it as add. B negative 5. Now you have one exponent, you can move it, but you don't move it all the way out. You move it as the coefficient of that log. So it's 1/2 3 log A plus negative 5 log B. If you want to, you can do a distributive property. So it'll be 3 over 2 log A minus 5 over 2 log B. And that's it. Okay. So that's the full expansion. So if you have a big exponent like a square root covering everything, then you can move it out first. But it would be like a parenthesis. So 2 more, I think a few more. Oh, a lot more. Yeah, and then we also have change of base formula. So this is condensed. So earlier we are expanding, now this is condensed. So what is the rule for doing condensation? So for condense, you want to make sure that you move the coefficient in first, right? Move the coefficient as power. It's kind of like reverse. Coefficient as power first. And then you can combine the add and subtract. The add and subtract. Add and subtract become multiply. Divide. Oh no, yeah, subtract become divide. So do I have any coefficients? So check. There's no coefficients, so I can combine them, condense them. So this is just 5x squared times 7x cubed. But because they are an expression that you can simplify, 5 times 7 is 35. X squared times x cubed is x to the fifth, right? Because x squared times x cubed is 2 times of x, 3 times of x is 5 times of x. That's totally condensed, nothing inside. So first look at if there's anything in outside of those multiplying different log terms. There's nothing, so you can condense right away. But this is dividing as divide because you're subtracting, right? 5x cubed over 2x. Now simplify inside. 8 divided by 2 is 4. X cubed divided by x is x squared. That's the totally condense and simplify. So condense this one. So you look at the coefficient. No coefficient. Oh, there's a coefficient of 1/2. We'll move this inside as an exponent. So it become ln x plus 2. This you don't have anything to move. Remember, this is inside. You can move them as multiplications. It is already inside. So minus log of square root x, right? Because x to the 1/2 is actually square root x. Now you don't have anything. You can divide them. ln x plus 1 divided by square root x. Subtraction become inside a log a division. Okay, so there's 3 terms here. 2 is a coefficient, so move inside first. So equal to log x minus log z squared plus log y. Now you have individual log with nothing, so you can combine them. Log, okay, divide means, okay, so, subtraction means divide. X divide c squared, and then times y, right? Should I times in the bottom or the top? It's a top times y. Because you're thinking of this times y over 1, so it's times y. So it's just whenever you add something, they move to the top. There's nothing to simplify, so this is it. Okay, the square only goes to z. So look at the coefficient that's directly in front of it. The main reason why we learn this log property is in chapter 3 we say, no, in 6.3 we say if we want to do a evaluate something of a different base, it's like log base 2, 5. How can I do that, right? So because in the calculator, most of the calculator, they only have log base 10 and log ln, log e. So we can use this change of base formula. So that means if I have a log base b, which is not 10 or not e, I can write it as log base 10 m in the top, log base 10 b in the bottom. So the base become in the numerator, in the denominator. The base become in the denominator. And actually it's also the same as ln m over ln b. Okay, so what's the reason? How come this become like this? So this is the proof. If you want to, you can look at it, but you don't have to know how to do it. You just need to know how to use it. Okay, so the way you do it is you say, okay, so I want to do log 2, 5. I'm going to just do log 2, 5. But I don't know what it is. So I'm going to add log base 10 on both sides. Right. So I want to do log base 10. Oh, I think I should do another step first before I do log base 10. So if I say this answer is y, then I would say, well, I use the exponential properties. I know that 2 to the y equal to 5, right? Now I'm going to do log base 10 of 2 to the y. It should be log base 10, 5. Basically, you are just adding a log on both sides, right? But once you see that, this is 2 to the y, this y can move outside. So my y would move outside as log 2. So this is by log property. And your 2 would be inside, and you have log 5 here. So this log is a base 10. So y would equal to, this is just a number, so it would be log base 5 of base 10, log base 10, 5, and log base 10, 2. So you can use a calculator to find what it is, and that's exactly log base 2 to the 5. Not to the 5, log base 2, 5. So if I'm to calculate it, I do log 5 divided by log 2, both are base 10, is 2.3. Oh, let's do it with the calculator. With a decimal calculator, we can go back here and use decimal. So log base, what was it? 5 over 2, right? Log base 5 over log base 2, 2.3219. So this is the same as, I wonder if you actually, they allow you to do, oh yeah, I think they do allow you to do log base 2, 5. Oh yes. I think in decimal, you can do that. They allow you to provide a base, so you can see that they're exactly the same. Okay, so the way you do this would be you do log, and then you do the underscore. If you do the underscore, it would shift down. You do it, and then you do a arrow to push it back up, like that. Okay, we'll talk about this in class. So what else? Oh, yeah, so try this. I do log base 5, 36. Okay, so we will use change the base to log 10 and change the base to L natural log. So we'll write it out. Log base 5, 36 is equal to log 10, 36 over log 10, 5. Also equal to ln 36 and ln 5. So we can find out what it is. Okay. Delete all these. We would use log 36 over log 5, right? 2.2266. Oh, 2.2266. You can check that if you do ln, you get exactly the same number. ln 36 divided by ln 5. 2.2266, exactly the same, right? So long as you change to another base that is the same, this is how you resolve a, or you can enter, you can find the actual value, approximated value of a base that is not log 10 or ln. So that is all for, I think that's the main reason why we teach the log properties, other than the fact that it's very useful in a future calculus class.